Hey everybody, this is Larry, this is me going Q3 of the weekly contest 444 maximum product of subsequences with an alternating sum is equal to K. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. I think this one, the hard part about this is just kind of defining the search space, maybe that's the way to put it. Yeah, so I honestly I kind of thought about this problem for a bit, and you can watch the live portion, and I wasn't able to get anything too clever. So I was trying to play around with these constraints, right? And being 150 is interesting, but yeah, and 12 is actually even more interesting. There is the 0, there's a factor of 1 maybe, but the rest, we have to do some maths. So the way that I end up doing is by doing dynamic programming. And this is honestly, I wouldn't want to say straightforward, but it's not a difficult dynamic programming in the sense that it just kind of, it's not straightforward, but it's a very standard take no take once you define the state, right? So the state is that we have index which defines 0 to n, right? It's just the index that we're currently manipulating. Sign, which I had from -1 or 1, right? So two things. Product, in this case, as the limit defines, is 5,000, right? And then total is going to be up to this big amount, right? And honestly, I could have made some optimization here, but we'll talk about that in a sec. But yeah, so you have some big amount, right? So the first thing that I thought about this was like, oh, well, I mean, if you just do the math, it's going to be way too slow, right? This is just n times 2 times 5,000 times, 10 to the 5th. Suddenly, I don't know, whatever number it is very big. And n in this case is 120, so maybe we'll just put that, or 150, sorry. We'll put that in here, right? And then I was trying to think about, and I did this kind of more on a more deliberate slow side. If I was in a live contest situation, maybe I would have YOLO'd honestly a little bit earlier, but it's just for the video, and just trying to figure it out, right? First thing about total is that, well, 150 times 12, so even if all the numbers are 12 times 150, well, what is that, right? Well, what is it? Let me plug it in. It's only 1,800, right? So then we immediately can reduce this to 1,800 times 2 for negative and positive, maybe. And then the other thing to notice is that if it's all 12, the total actually cancel each other out a lot, because you can't just have things in between, right? So the total actually now reduces to the max total. Well, the max total is 1,800, but you can have odd parity things, right? Actually, I guess you can. But what I mean is, what I mean is that you can have, the max number cannot be 1,800 because it's not just 12 times 150, but because you have to subtract every number. So now maybe alternatively the thing is 12 0, 12 0, 12 0, 12 0, right? And as a result, you just divide it by 2, so it's 900, right? Okay, so now we reduce this. This is still too big, right? This is about 2,000, but even say, so this means that this is about 10 million, and then you have to times it by 2 and then 150. Still too big, right? Okay. Yeah, I mean, and you could kind of get a little bit tighter with the bound, though it's still a little bit, I mean, but not much tighter, right? Because it can actually be 900, or if 900 is the max, it means that it's always going to be a multiple of 12, right? Because you can't have 1s or 2s or whatever. I mean, it's not quite scientific, because you can actually add I don't know, maybe a few numbers to kind of, and that's all you need to kind of shift them more. But it's, that it's smaller than that, maybe not by much, but right. Then the next thing is product. Because I don't think I could do, well, sign is just 2, so I wasn't thinking about it that much. But index was an interesting one for me, right? And what I mean by you can't really get away with index, so the product's the interesting one. I go 5,000, okay, 5,000 seems a little bit unreasonable, and then I saw, okay, well, it goes from 0 to 12, right? So I asked myself, so that means that only numbers that are multiple of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, and 11. I don't know why I said in that order. Is eligible, right? And if you watch the live portion, I actually ran a for loop. I mean, I could live write it again probably, but just something like, yeah. So for I in range from 1 to 5,000, right? So if, so we have for J in range from 2 to 12 inclusive, so it's 13, right? So while I mod J is equal to 0, we divide it, right? And then if I is equal to 1, then good increment, right? And then we could print this out real quick, something like that. And we just kind of run it, and you'll see that this is 394, which I round up to 400. So that means that there are only 394 distinct numbers for which this is true. So that means that now your product is 400. And then now, what does that come out to? Actually, I don't know. Right? Still too big, but because it's about 217 million if you kind of do this multiplication. But it was at least close enough for me to YOLO. Honestly, I don't have a tight bound for you, but I just thought I could YOLO. And why can I YOLO? Well, the reason is that I just kind of thought about it like, okay, just ignoring, ignoring, so there are multiple dimensions, right? But let's just say we only think about index and product, right? Well, what does that mean? Well, the first number, for the first index, you only have you only have 1 possibility for product. For the second number, you only have 2 possibilities, maybe 3, and so forth, right? So it goes like incrementally like that, right? So as a result, a lot of the states are not possible on the product side in the beginning, especially the beginning anyway. And then also the same with total. It's not super scientific, but you know, like for example, if you could get the 900 with all of them being 12 and zeros and 12 and zeros, well, in the under the first index, there's only 1 possible value. Under the second index, there's maybe 1 or 2, I guess 12 and 0 or something. And then after the third index, it's going to be 0, 12, and 24, right? And so forth. So a lot of this is actually, a lot of states are not actually that possible as a result, right? It is in the beginning. So I thought maybe yeah. But those are the ideas that I had for YOLO. To be honest, I don't know that I didn't see a title bound posted. So if you did see, if you did see a bar, then let me know. So I kind of wrote this, and this is just a simple tick, no tick, right? Tick is if it remains under the limit, we just invert the signs, update the product, update the total, right? And no tick, well, just no tick, so we just update the index. Also update the index here too. And that's it. Yeah. But the reason why I had to rewrite this part is that, well, you have to at least include 1 number. So I got a wrong answer of that, very silly mistake. So, and then the second wrong answer of this too, because I forgot that if you include 1 number, that number has to be under the limit. Again, silly mistake. Maybe I have the if statement inside here, then, if I have an if statement for if product is equal to whatever word a mistake. Anyway, 2 wrong answers from this, right? It is what it is. But then I realized that I missed a case during the part. Wow. So there's this case where, I mean, even on, I don't know. Even if you just kind of add, yeah, I mean, I don't know, just adding a 0, right? So for example, maybe your product limit is equal to 6, right? So actually, even just take this one. If the product limit is okay, whatever. So okay, so the reason why it cannot be is because k is equal to -5, so that's not possible. So this is the k. Let's say the limit is 2, right? And the k is equal to 1, right? So you -1 maybe, yeah, -1. No. In this case, it has to be okay. This is a bad case for me, but yeah. Let's just say you have some thing, right, where actually the other way is fine. So you have this, right, and your limit is -1, right? Well, 2 and 3 is a possible answer because this just goes to -2. Oh, sorry, 2 minus 3, right? But so this matches the -1k, but it goes over the limit because product is equal to 6. However, the thing is that there may be a future 0 And if there's a future 0, this brings the product to 0. And it's still possible, right? Because this is just plus 0. So that's basically the case that I did not consider because of this, because of this product constraint, right, that I had. So what I did was that I just go, okay, well, I'm going to calculate this best thing, right, for all the best products, keeping in mind that my base case, that is, if total is equal to k, we return the product, right? So we just kind of do this, and we returned it for all the possible first numbers to kind of precede the first number, right, and including the limit. Okay, so that, and yeah, so if this is possible for any number, best is going to be non-negative 1, or maybe it could even be 0, it doesn't matter. But I just kind of did the thing of, okay, I mean, if the answer is 0, then you don't have to do any more work because that's your best answer anyway. But if the best is impossible, then maybe I skip the case here. Oh, I deleted it already. I skipped the case that we had where there's a future 0, but because we don't consider future 0s here, then yeah, because we do not consider future 0s because it temporarily put us over the limit, I just wrote a second DP. That is basically the idea. Let me erase this because it bugs me. Yeah, I just have a second DP, right? And this is the same thing, except for that index is, again, 0 to 150 or so. Sign is same, plus 1 or negative 1. And then 0 is just true or false, whether we've seen a 0. And total is just total, right? So it's like 0 to whatever, total, same total, right? And I thought that if this is good, then this is good. I mean, if the first one is good, this is going to be better just in terms of complexity. So I didn't really think about the complexity at this point because, well, 0 is going to be binary and product is 400. So it should be good, right? So yeah. And then the base case is basically the same. If total is equal to k, we return we return true if we've seen a 0. That means that the entire product is 0. Otherwise, we do a tick, no tick. I kind of wrote it like this in OR statement. This is the OR part, right? So it's basically this or this, right? And yeah, and this is just tick, no tick, right? We update index, update sign, update whether we have a 0, and then update the total, right? And maybe I didn't explain this part, but the update total is just the total plus the sign times the index, right? So it's negative 1 or plus 1, so it's plus or minus, and you alternate every time. So that's how I kind of wrote it. And not, then this is no tick, right? So this is tick, no tick. And that's it. I also start off try every number again, right? But only if it was impossible, then we try this again to see if it's possible with a 0. And yeah, and we try every number and we start it off with whether the first number is a 0. And yeah, that's the base case, and you have a negative 1 as the thing. And that's it. Yeah. So 2 dynamic programming solutions is how I kind of squeezed it in. I do have hopefully this makes sense. And the complexity, I don't know. You can say this how you want it. It's confusing. But yeah, so one trick that I actually saw Alex mentioned, Alex Wise, obviously smart dude, but he mentioned that instead of writing a second DP, which I did, you could have actually baked it into the first DP. You could actually set, instead of this, you do maybe, instead of this, you remove it so that you always do the tick, but now you want to limit it by, limit plus 1, right? And the reason why you limit it by limit plus, not max, this is a min, whoops. And people may, let me interrupt a little bit by saying that people ask me why I write out the function is because it's just so much faster if you do that operation many times. And we do, because we have a lot of recursive, right? So that's why I turn it there. And the reason is because the native min function takes in a where args, and it does kind of more work to kind of variable argument, so it kind of does a lot more work to kind of figure that out and then take the min and put on top, where this is just, even though there is a function overhead, it is just a really short if statement, right? So, and it knows that it has two parameters and so forth. But anyway, yeah, the reason why this works is that basically when product times num sub index, when it goes over, well, it goes reset to limit plus 1. And the reason why limit plus 1 is good is because then now it gives you it dupes up all the cases in which you're already over the max. You can think about it as a flag that is, oh, product is already too big, right? And then now all you have to do is here is, and if product is less than or equal to limit. And that's it. And the reason why this is good is because then now if nums of index is 0, if it's ever 0, this entire thing will always be 0 in the future, right? In the future branches. So you don't have to consider that as a separate case. And that's basically it. And then now that lets you remove all this code and clean it up a little bit. Remove this thing. And yeah, and I could even fit it into one line. Actually, let me, before I lie to you, let me run it. Let me give it a submit. And making sure that I didn't make a silly mistake somewhere. And yeah, as you can see, pretty well, it AC'd anyway. And yeah, and with all the thing. But that said, you know, at the end of the day, you just have to figure out how to solve things, right? And it doesn't have to be, you know, this way. It could have been the way I did it too, because, you know, it's still an AC no matter how the computer sees it. And that's it. Yeah, let me actually, while on screen, kind of see how much, see if it's faster or slower. Because I am curious. Oh, it actually turned out to be slower than the two solution. So I don't know, why is that? Actually, I'm not quite sure why it's that much slower. I mean, I think the reason is probably because this now does a lot more recursion on states that we weren't considering before. Because yeah, I think that's probably the no. Actually, I don't know why it's that much slower, because we do the same thing on the thing, but yeah, I don't know. So maybe this is a little bit cleaner and faster to solve, but it runs actually faster or slower. Sorry. So I don't know. Take your pick. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and you could watch me solve it live during the virtual contest now. Okay. Reasonably sure because I've done it enough times, and then, but you know, Q4 seems to be easier than Q3. What are the point totals? They're both 6. Okay, doesn't matter. Let's do Q3. Okay, maximum product of subsequences. I should be able to do both, right? So it should be fine. Maybe, I don't know. We'll see. Maybe I change my mind and I'm wrong. Let's take a look at the leaderboard. I mean, it's cheating leaderboard, but oh, there's the ranking. No. What a silly mistake, but seems like people, okay, are able to get it pretty quickly. I guess that's actually cheating, but I just wanted to actually look at just the first 2. I'm really behind. Actually, a lot of people took a lot of time on Q2, so I don't know what that's about. Okay, so maybe I'm not that far behind, and I'm talking a lot, so, but yeah, okay, let's take a look. Nums, K and limit, non-empty subsequence, alternating sum, you go to K. What's an alternating sum? Sum okay, sum of the elements at even indexes. Okay, fine. Maximize the product always numbers without the product exceeding limit. Return the product of number subsequence. Okay, so the subsequence with an alternating sum of 2. So okay, what's n? N is 150. That's interesting. Numbers of I is 12. What is K? K is the sum that we care about, but nums of I is 12. Huh? Can we even get to like 10,000? I guess so. 12 times... No, it's just like 1,500 or something, right? So what's that about? It's a little bit weird, but okay. Limit is the product limiting, right? Maximize the product without the product exceeding limit. Okay. It's a very weird one for sure. Alternating sum. So there's a lot of parts about this one. A lot of moving parts. How do I even figure this out? Well, I mean, there's only 150 numbers, so we should be able to do it. Product. Product is limits 5,000, so maybe just put standard DP, maybe? I don't know. So you have the index, you have the sign maybe, and then you have the current product, and then you have the current sum, right? So what's that? Product is 5,000, index is 150. Oh, let me put it on a calculator. 150 times 2 times 5,000 times total. This total could be pretty big, which is like 150 times 12 or something. So that would be too big. Okay, so that's like 1 billion, or maybe 1 trillion. I can really read the number of zeros. So okay, so that's definitely too big. Is it though? Can you do all the products from to 5,000? No. How many primes are there under 5,000? Primes under 5,000. How many? Maybe I should ask ChatGPT. I'm trying to like look for a list. But where's Google Gemini? Is it supposed to tell me? Oh, 669 primes. So that's not enough to eliminate enough, right? We have 150 numbers, so you should be able to construct every other non-prime. Let's see. Alternating sum equal to k. Subsequence. I don't know. I feel like I want a YOLO, but I honestly not sure about this one, the complexity wise. Because limit the current total is a little bit awkward as well. Total is not, I mean, it's 150 times 12, like 1,800, so it's like 2,000. But actually that's not even possible because it's alternating. But then you could get maybe negatives. What is the maximum possible sum, right? So maximum possible sum would be 12 minus 1, so 11 times 75 maybe. So 825 times 2 for both signs. Is that even possible, both signs? Yeah, you could just offshift by 1. So it's 1650. So less than 2,000. The total would be less than 2,000. We can definitely throw away stuff that's not possible. Product has to be less than limit. Product. Oh, but product is a weird one, isn't it? I think it's just about handling ones and zeros. Oh, product being 0 is... Oh no, but you want to maximize it, right? So that's a little bit curious. Can you ask if it is possible instead? Well, the current product is the thing, right? Okay, so you instead of going the other way, well, okay, 2 to the... No, but it's not about the number. It's about the number of distinct things, right? Well, there are a lot of numbers that are 2 times like a prime, right? That is bigger than 12. So there's some proofs there. So it's not, might not be 5,000 either, or even 4,300 or whatever it is. It's just like 2 times 13 would make it. Or even multiples of 13, right? So you already remove 13, you remove 17, and all the multiples, then it is not that many numbers that are possible, right? I don't know. The part that I'm struggling is with whether I should write a proof out, and maybe it's not that bad. Okay, fine. Let's just write it out, right? So possible is equal to force times n. Okay, so we can write this code pretty quickly. So maybe I should have just write it. We don't care about ones. We we'll ignore zeros, right? Because it'll just is it always possible? Oh no, -1. So we can't ignore 0 because it may be that the possible answer is 0 if it's possible. Okay, well, whatever. Okay, let's just try this real quick. J is equal to I, while J is Okay, whatever. Possible sub j is equal to true. J right? Otherwise, it's not possible. So for I in range from whatever, it doesn't matter. If possible sub I, right? Yeah, okay, whatever. Okay, so it's still 4,000. So there's still more numbers are possible. No, I did this wrong. No, this isn't right. This is. I should go the other way. No, this is wrong. This is wrong. So okay. No, this is wrong. So okay, so maybe I should. Okay, so let's just do the square root way. It doesn't really matter. Why am I trying to sift this? Right. So okay. So then now, okay. So j is equal to 2, right? Okay, maybe okay, we start from well, we start from 1, it doesn't matter. But for j in range from what? J is equal to 2, while j is equal to I, then well, I might j is equal to 0. J increment by 1, right? And then basically now, and j is, well, maybe I can just write j in range from 2 to 13. And then now we have if I is equal to 1, or not equal to 1, then okay, that's actually accurate. I did the math wrong. There's still a lot. Am I wrong? No, this is, wait. Maybe, no, this is, I counted the wrong thing, actually. Yeah, no, so that means that I counted the inverse of this. So this is 5,000 minus this or something. But, which is, okay, so this is only 390 distinct, right? So what's the math again? Okay, so it's 120. I should, maybe I could have YOLO'd, but I wanted to show my thought process. It's fine. Okay, so okay, 1800 as I said for the first 2 times what did I say it was 390, or just make it even 400 times total. Total is another 2,000. This is still too big though. That's still 1 billion, so that's not great, right? I mean, it's good that this is only 400 on the product. 400 possible values. Right? Well, okay, wait a second. 400, well, okay, let's think of it another way. Okay, maybe I was too thinking of DP. But 5,000 means that, was it 2 to the what? 5,000 log 2, I think. Where's my button? Okay, whatever. Was it 2 to the 10? It was 2 to the, like 2 to the 13 or something, right? Yeah, so 2 to the 13, that means that we only need 13 numbers. So it's n select 13. So 150 choose 13. It's not even quite that, because that number is ridiculously big anyway. It's that, okay, so if that's the case, then what? Then we choose the number of things, so the index and the sign actually, this would only have, we can reduce index to 12 with a little bit of a loop, maybe. To reduce the number of counting. Order does matter though, so I don't know. Oh, but this order matters, so you can't just group them together. Huh. That's a really wonky one then. I don't know how to optimize for this, maybe. Maybe I do, I don't know, but... okay, so product is equal to 400 different things. I think, yeah. Yeah, I printed out. Nope. I did print it out. Okay, it's fine. Hmm. 5,000. Can I work backwards from the answer? N is equal to 150. Product. There's only 400 distinct products. The sum. Can I get rid of one of these dimensions? I think that's what it comes down to, probably. Well, total is not. What did I say the number is? I guess total it's not all filled out. So it's not just straight up multiply. YOLOing is so hard though. Maybe I should have YOLO. I don't have any other crazy ideas. So maybe we'll see how it goes. It should be easy to test-ish. Okay, well. I don't know. Maybe I should have written it, but maybe I should have skipped, maybe, I don't know. If what am I returning here anyway? If x if total if product if total is equal to k, then we are Gucci, right? And we return product, assuming that product is always less than whatever anyway. Otherwise we return -1, which is fine. And then otherwise, then here we just take no tick, right? So go index +1. -1 times sign, or negative sign, maybe that's fine. Product times num sub index total plus sign times num sub index. Right, so tick if product times num sub index is less than or equal to limit, right? Okay, and we call this, then now we go skip, which I guess is just the same. I guess that could have been a default case, but product is 1, total is 0. I mean, it's easy to write, it's just whether it's wrong or not, when probably I don't even get that one right, so maybe I shouldn't have been so whatever about it, but I got one of the answers right. 1, 2, 3 is 2. Product is 6. Product times How is this wrong? Why is it wrong? Is it here? Total is equal to K? Okay, well. I don't see anything obvious, but maybe the input. Sum is 1, okay, 2. I mean, if you have or 3, this is what we want, right? Did I mess up the total is equal to K? Total is equal to K, right? Is that not this one? Why is that 3162? So this is return 6, right? So returning 6. So why am I getting -1 as a max? Am I just being dumb? Okay, yeah. F max as well. I am a dumb boy. Okay. Honestly, I don't know that this is fast enough, other than me making that silly mistake. But I guess we should construct a case, right? Okay, so we want nums is equal to, I don't know, 1 times 5,000 maybe, or 150. K is equal to 150 maybe. No, it can't be that big. So 75. No, it will always be 0 actually. So alright, limit is equal to 5,000. Is that fast? That is fast, but I don't know if that's the right thing to do. Let's just say a K that's not possible. So we export all the states, but that's because all the products are the same, right? So maybe we have 2 or something. 2 is still pretty fast. Okay, I mean, I don't know. That's YOLO. If not, then they'll hopefully give us a case that we can use. This taking a long time is not great though. Oh, did I not handle the 0 cases? Output 1. Why would it output 1? Product is, oh. Wait, what? Index, so it's skipped. But okay, so that's actually pretty reasonable. We didn't take any number at all. So we have to take at least one number. So that's what which I don't do. So that's actually a legitimate wrong answer. That's fine. I'm still worried about it being fast enough, but that's okay. So you have to take at least one number. So, okay, fine, right? That's my bad. Go index plus 1, -1. Was it num sub index is the product, and then total is num sub index as well. Okay, right? Okay, so I didn't take a almost one clicked. Okay, so that's right now. I'm still worried about the time limit case, but hopefully. Wow. Expected -1. Oh, wait. Oh, man, Larry. I had this here so that I could save a function call here on product, but here I didn't have it, so okay, fine. Okay, now I'm getting a little bit annoyed. I'm still worried about the time limit case, and I don't even have this case figured out. So that's a little bit sad, because it's still, oh my. Okay, I'm just like really bad today. Okay, but so the sum is 20. Why do I not just output is -1 because it thinks it's impossible? But what is the possible case? Oh wait, is the sum 20 or the sum is 1? So it's gonna be 10 plus or 10 minus 9, maybe. Why would I need the 0? What is the order of this thing again? What is the -1? What was the 1? Oh, here 1. So the limit is 20, so you have to pick one number. I don't get it. Why is it oh wait, no, expected is 0. I put -1. It is why is it 0 though? Limit is 20 for multiplying, so how do you get 1? Am I misreading the product by or number without? Oh, I see. So the states are right, but is that when there is a 0? Oh, so you have to be able to go through this because later on could be a 0. Okay, how do I handle this case? I think technically speaking, we just do this, but then now the numbers could get really big, right? And now we lost some parts of this. I mean, we have to put it here actually, but and product is. But now the complexity gets pretty big though, right? So yeah, so now we definitely, now definitely, I don't know if oh. Okay, I think no, this doesn't mix. This is too expensive. So we have to do whether we can do 0, right? So okay, so we have to write another function. Oh, that's pretty bad. I mean, this is actually a real thing, so I think that's fine. And then now we have to do, can we do it with a 0? And the product doesn't matter anymore, right? So we have another function, maybe. Also, I probably should have done go.cacheClear, right? And then now we have another function for go, right? So go2 maybe, index, sign, total, right? And we have to hit a 0. So maybe we have to go 0 yet, so the product doesn't matter, right? So 0 is used or not. And then if index is equal to n, then if same thing really, okay, then we turn true, right? Or if 0, we turn true. Or just return 0, I suppose. Otherwise, we return false. We have to hit a 0. Okay, so then now we just take no tick. Go 2 of index plus 1. Negative sign. Okay, if num sub index is equal to 0, then we can. Okay, so do the tick no tick first. Num sub 0, then the tick will take this to be true. And then total and whatever, just write everything else. I guess this is just whether this is 0 or this thing, right? So we turn this or tick no tick, right? So index plus 1, negative sign, 0. Oh no. We don't change anything, Larry. What are you doing? This is no tick. Okay, so something like that. And then we have to write it again, which is that, right? If, okay, so here we go, if go to, and this is all for not if, this is all for not if it's still too slow, which I'm not certain about, right? So if this is true, then we return 0. Otherwise, we return best. Okay, so we got that. What's the expected answer again? I don't remember all the other. Okay, so it's 6. No. This is -1, and this is not okay. So we got this one wrong. Because -5 doesn't exist, but why does it think it exists? So so this is plus on the nums index. So that's, do I not, if total is equal to k, return 0. So why is it, okay. go to index plus 1, -1, because we took this number and this is a 0, right? What? Why do you think this is possible? Possible -5. Index plus 1 sign. So this is true near 0, right? So okay, so why? Tell me why. Okay, I mean it fixed the other thing, but lucky I checked that one, but okay, let's actually remove the first case, so then we can see. Okay, 1, -1, 0 is true. Okay, but the total is 0. Yep, that's expected. And then this goes to 2, true, -2, also okay. But then does this return a true? Does it? Oh, I have go here, that's why. That's a sloppy mistake. Okay. Okay, so that looks like it's okay now. That's what happens when you name things too similarly. Okay. Still have a possible timeout issue. Also, Chef, maybe remove this. But that's a annoying. But how am I doing on time? Like I probably could have done that one without 3 wrong. Maybe 1 wrong answers is okay. The other 2 was just silly. But thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, this contest, the explanation, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.